All right, for example number 7, we have to guess the equation. So this is, in the real world, like if Mr. Adams is doing research at Notre Dame or Northwestern or whatever, we usually get data, and the data has a shape. And then I have to sometimes figure out what equation fits that shape. And so this is a great example of how it's used in the real world. So let's pick a function first, sine or cosine, and then tell me why. Cosine. Why do you think it should be cosine? What's that? Oh, that's good. That's a good. So the student said cosine because it's symmetrical about the y-axis. It's an even function. So that's good. That's good. So we're going to go with cosine. So now let's start with a. Remember that the range is negative a to positive a. Right? Remember, that's the range of the trigonometric function, either cosine or sine. So if we want to figure out a, we just got to look and see what the amplitude is. Remember that a stands for amplitude. So what is the amplitude? 3. Now, we know also, let's think about this too. We know for a fact that cosine kind of does this thing. That's what cosine looks like, right? Well, it looks better. It looks better than it. It kind of looks like this. It's so hard to draw with this tablet. So that's what cosine looks like. What do you notice about our function compared to cosine? Well, it's not compressed, but also we start up here. Where do we start here? Down here. So what does that tell you about a? It's negative. So we suspect that a is equal to negative 3, right? Does that make sense? All right. So now we have y equals negative 3 cosine b times x. Now remember, the relationship for b is that the period is equal to 2 pi over b. So let's go from here to here. So if I go from here to here, what's the distance from here to here? In other words, what's the period? If I go from here to here, I go through one complete cycle. Right, so I go up and come back down. No, it's just 8. It's just 8. So we would say that the period of the current function is 8, which is equal to 2 pi over b. Now, to solve this algebraically, you have to multiply both sides by b. And you get 8b is equal to 2 pi. Then you divide by 8. And we literally just did this question. So b, this cancels, b is equal to 2 pi over 8, which reduces down to pi over 4. So then our equation is y equals negative 3 cosine pi over 4 times x. Now how do I double check that? Plug it into Desmos. So I'm going to say negative 3, was that sine? No, it was cosine. So it's going to be negative 3 cosine pi over 4. And it goes from here. Oh, my bad. Okay, now it'll work. From here to here. Let's take a screenshot of that.